Good morning. So today I am going to discuss about the free body diagram for the block systems. To study the free body diagram we need 5 steps. In that, what is free diagram? Free diagram means it is a diagrammatic representation of any one of the system. That system is exposed for what kind of forces. So for that, first step 1 means a reference frame. We need to know what kind of reference frame in the system. So here the reference frame, we have two reference of frames. One is non-inertial frames and another one is inertial frames. Non-inertial frames or inertial frames. So we need to check either it is inertial frame or non-inertial frame. If it is inertial frame, the frame of reference is at rest. If it is non-inertial frame means the frame of reference is also is in motion. Now step 2, decide the system. If the two blocks are combined like this, what is shown in A, B, C. So carefully if you observe, the system what you want to take to study the free diagram, either A or B. If suppose I want to study the A, then I have to choose as a system is A. So now this is the system. If I want to study the only body B, then I need to choose the system is B. So here the system is B. If suppose I want to study the both the blocks as a system, then I want to take it as a system, this is one. So here first we need to, step 1 is either the frame is inertial or non-inertial, we have to choose. Step 2, we need to decide the system when the combinational blocks are placed. And step 3, identify the external contacts and forces for a system. Now for this system, I need to find what are the forces or contact. Now let me see. Suppose every block is in downward direction due to the gravitational force which is mg, and due to this there is a normal force is in opposite direction as according to the Newton's third law. For every action there is equal and opposite reaction which is called as normal action if the system is A. And if the force is applied externally on the system, then the opposite force will be existed as normal force. For this force, this is the opposite force. And when the system is in contact with a surface, then there is a frictional force is also existed like this. So these are the forces or contact forces, and that we need to find in the step 3. And step 4, choose coordinate system and draw the acceleration diagram. So here we need to choose the coordinate system for this acceleration. So the same things here I am going to apply. This is the applied external force. This is the normal reaction for the system, and here it is the frictional force, and here it is the gravitational force mg, and here it is the normal force which is opposite to the applied force. But here when the force is greater than the n1, when it is in motion, that means a frictional force. If the frictional force is small, then the applied force will be existed to get the acceleration. Now the F is applied in the x-axis. Now the acceleration is also in ax. So now the acceleration is ax, and here acceleration is ay. If the applied force is in x-axis, then acceleration is also in x-axis. And this is the coordinate system, and draw the acceleration diagram. Either acceleration is in x-axis or y-axis. That will give the direction, either it is in horizontal or vertical. And application of the F equal to NB. Now we can find the applied force what we are applying on the system. That system mass you have to substitute here, and the acceleration we will find if you know the applied force. Otherwise you can also find the displacement how it is taken. So m, where a is equals to v by t, and f is equals to m, where v is equal to s by t, then it is s by t square. So by using this we can find either velocity, displacement, force, and time and mass if you know the application of the F equal to m here. Thank you.